Now we'll see the second problem, Z transform. So Z transform of, this is a causal signal, this is a non-causal signal. So Z transform of any signal is a summation n equal to minus f to plus infinity given signal z power minus n. So send the summation inside and z power minus n inside. Summation n equal to minus f plus infinity 1 by 3 whole power n u of n, this one. Because of this u of n, limit is going to change, and because of u of minus n minus 1, the summation limit is going to change. It is a u of n equal to 1 when n greater than or equal to 0. That means this n is 0 to infinity. This is a n is a negative. When n is a negative, the starting point is a minus infinity. Ending point means equate this entire one is greater than or equal to 0. So u of minus n minus 1 equal to 1 when this inside is greater than 0, positive number. From this one you will get n less than or equal to minus 1 equal to 0 when n is greater than or equal to 0. That means u of n equal to 1 when n equal to 0 to infinity. This u of minus n minus 1 equal to 1 when n is minus infinity to minus 1. Now I am going to this anyway, it is a summation is a positive. I am going to convert this entire with something power n. So 1 by 3 z inverse whole power positive n plus n. The limit is also plus n. Now this limit is a negative. Let me convert this entire one is a whole power minus n first. After that I will change minus, both minus here. So limit is summation is a negative. I am going to convert something power minus n. 1 by 2, this is a whole power n. I want a minus n means 2 inverse. Otherwise 1 by 2 whole inverse z whole power minus n. Now something power n, give this minus sign varies from minus input to minus 1 means take this minus and put it here, then minus of minus plus. So n equal to 1 to infinity. This is a 1 by 2 inverse means 2z whole power n. Summation is a positive, something power n. Summation is a positive, something power n. Before going to the next step, we can find the ROC. ROC for first one is if the summation must be finite if this entire one mod of this entire one is less than 1. So 1 by 3 z inverse must be less than 1, and this summation is finite value when mod of 2z is less than 1. Then I am using the and symbol because that is a plus. Whenever it is a plus, we can use the and symbol, otherwise intersection. From this one send this we can write z inverse 1 by z, send this z to the right side, then you will get a mod z greater than 1 by 3 and mod z less than 1 by 2. This is the combined, and means combined area. First I am going to find the poles of this one. Poles of this one is z equal to 1 by 3. Poles of this one is z equal to 1 by 2. So first one is a mod z greater than 1 by 3. First one is mod z greater than 1 by 3. So 1 by 3, poles is 1 by 3 and 1 by 2. Star indicates poles. Poles are indicated by star mark. 1 by 3, mod z greater than 1 by 3 means take a circle with a radius 1 by 3. Mod z less than 1 by 2 means take a circle with radius 1 by 2. Mod z greater than 1 by 3 means exterior to the circle of radius 1 by 3. Mod z less than 1 by 2 means take a circle of radius 1 by 2 interior, inside. So mod z greater than 1 by 3 is indicated by red mark. Mod z greater than 1 by 3 is indicated by pencil, by using pencil, and mod z less than 1 by 2 is indicated by red mark. The combined area is, this is the combined area. Combined area is mod z greater than 1 by 3 and mod z less than 1 by 2, combined area. So ROC is exterior to the circle of radius 1 by 3 and interior to the circle of radius 1 by 2. It is a combined area. It is a disk or ring whose area is exterior to the circle 1 by 3 and interior to the circle of radius 1 by 2. Now Z transform ROC. So we can stop up to here. Otherwise, if you want to compare this result with first problem result, I am going to rearrange. Take minus 2z outside in this one. Keep this one as it is. Take minus 2z outside, then we get minus 2z. 2z gets cancelled. You will get 1 by 1 minus 1 by 2 z inverse. So Z transform of second problem and Z transform first problem must be equal. You can check it out. But there is a change in ROC. For second one, ROC is mod Z greater than 1 by 3 and less than 1 by 2. If you take the first problem, the ROC is mod Z greater than 1 by 2. That means the Z transform of first two problems are same, but there is a difference in only ROC. Now we will see the Z transform of impulse and the Z transform of A power mod n, where A is always less than 1, then only Z transform exists. So this is the second problem, is an important model. This is many competitive exam, they will ask this Z transform. So Z transform of given signal summation equal to minus 50 plus 50 x of n Z power minus n. Now replace x of n as a del of n. So del of n means impulse sequence. Del of n equal to 1 when n equal to 0. This n equal to 0 is available within this summation range. The n varies from minus 70 plus 70. In minus 70 plus 70, that is 0 is exist in between. So this result is Z power minus n at n equal to 0. When n equal to 0, del of 0 is 1. So Z power minus 0 is 1. What about the ROC means? ROC is the entire Z plane. It depends upon n equal to 0 only. If you take left side or right side, wherever you want. So ROC is entire Z plane for impulse. Now Z transform of A power mod n. We can write a mod n as a mod n equal to minus n when n is less than 0 and mod n equal to plus n when n is greater than or equal to 0. So I am going to split this interval n equal to minus infinity plus infinity given signal Z power minus n is equal to, I am going to take when n is negative, when n equal to minus infinity to minus 1, A power minus n. The mod n will become minus n, Z power minus n, plus when n is a positive, when n equal to 0 to infinity, n is a positive, then A power mod n will become plus n, this one. Now I am going to rearrange this equation. Check this one. This is the summation. Is n value is a negative. I have to convert, because this n value is a negative, I have to convert something power minus n. Because n value is a positive, I have to convert this entire one is a something power plus n. So because n is a negative, A, this is A inverse now, can take A Z power minus n. N is a positive now, A Z inverse whole power n. Now give this minus symbol to here, then n will become positive. N equal to 1 to infinity, A Z whole power n. N equal to 0 to infinity, A Z inverse whole power n. Summation is, summation limit is positive, power n positive. Summation limit is positive, whole power positive. Now before we go to the next step, we can find the ROC. ROC of first one. If this is convergence, if the summation must be, if you want the summation must be finite value, then A Z inverse must be always less than 1. That means modulus of A Z less than 1, then only the summation is convergence. The same way the summation is a convergence if mod A Z inverse is less than 1. Because symbol plus, I am using the and or intersection. Or send this Z to the right side, then mod Z less than 1 by mod A, and send this Z to the right side, then you will get a mod Z greater than mod A. But in the problem itself they given mod A is less than 1. Okay now combined ROC is mod Z greater than A and mod Z less than 1 by mod A. And ROC, this Z transform, this one is, because n starts from 1, first term is AZ. First term is AZ by 1 minus AZ. Because here n starts 0, first term is AZ inverse whole power 0 is the first term, 1 by 1 minus. Now you can stop up to here, otherwise you can proceed the next step also. AZ by 1 minus Z. This is Z transform, and the combined ROC is, because A is less than 1, first it will come, poles are indicated by star marker. For this one pole is 1 by A, for this one pole is A. So A 1 by A, because A is less than 1, if you take A is 0.5, it is 0.5, it is a 1. That is why first A will come and the second one 1 by A. So combined means it is a ring. This ROC is a exterior to the circle of radius A and the interior to the circle of radius 1 by A. see the properties of Z transforms. First, anyway, if you check the CTFT properties, DTFT properties, Z transform properties, almost all are 70% or 80%, all are similar. We have to change this somewhere, some formulas only. The remaining all the steps will be similar. First property, time shifting property. If the Z transform of x of n is capital X of Z, then what is the Z transform of x of small x of n minus k, where k is some constant. It may be positive or negative. Now, what is Z transform of x of n minus k? We will say the proof. Z transform of given signal is equal to summation n equal to minus z plus infinity x of n minus k z power minus n. So, I am going to assume this n minus k is equal to some constant p. From this one n equal to p plus k. Now, lower limit is n equal to minus infinity. Put n equal to minus infinity here. You will get n equal to minus infinity. You will get p equal to minus infinity minus k. That equal to p equal to minus infinity is a lower limit. In this case, upper limit is n equal to plus infinity. Put n equal to plus infinity, then you get p equal to plus infinity. So, I got lower limit as a minus infinity, upper limit as plus infinity. X of this n minus k assumed p, replace p, z power minus, I am going to replace this n as a p plus k. So, it is a z power minus of p plus k. You can write it separately. Z power minus, send this minus inside, z power minus p into z power minus k. Bases are equal. You can, if you add the power, you will get the same term. Okay, now I am going to, because this is summation is in terms of p. The summation is p varies from minus infinity to plus infinity. X, this is x of p. It is a function of p. Z power minus p. It is also a function of p. Z power minus k. It is not a function of p. That's you can take z power minus k as outside. Into z power minus k into summation p equal to minus infinity plus infinity x of v z power minus v. This is nothing but z power minus k into this entire one we can write as a capital X of z. So, z transform of x of n minus k is z power minus k x of z. It is called right side shifting. Next property, time reversal. If z transform of x of n is x of z, then what is the z transform of small x of minus n? We will see the proof. All steps are same, similar to the DTFT. Z transform of given signal summation n equal to minus n plus infinity, given signal z power minus n. I am going to assume minus n equal to p. From this one, send this minus to the right side, n equal to minus p. Now, in this equation, lower limit is minus infinity, upper limit is plus infinity. When n equal to minus infinity, then p will become plus infinity. When n equal to plus infinity, then p will become minus infinity. Now, I am going to convert this entire equation in terms of p. So, n equal to, when n equal to minus infinity, p will become plus infinity. When n equal to plus infinity, p will become minus infinity. X of minus n, I assumed p, x of p, z power p. So, I am going to rearrange. This is not a capital X of z. I want here it is z power minus p. Then only z transform you will get. So, to get z power minus p, I am going to make small arrangement. Anyway, I am going to interchange the limits. P equal to minus infinity plus infinity, x of p, z power minus of minus p. Minus into minus plus, you will get the same z power plus p. I am going to write z power minus 1. I can write this one as z power minus 1 whole power minus p. Now, check it out. Assume it is a summation p equal to minus infinity plus infinity, x of p, z inverse whole power minus p. Just like a general formula, you will get a capital X of z inverse or z power minus 1. So, z transform of x of minus n is capital X of z inverse. We will see the multiplication by an exponential sequence. Exponential sequence in case of discrete is indicated by a power n. Exponential. If it is a continuous time, then exponential signal is indicated by e power t. But in case of discrete, e power t, we are going to assume it as a multiplication by an exponential sequence. If it is a continuous, e power t or e power minus t. If it is a discrete, that exponential sequence is indicated by a power n x of n. Then what is the z transform of a power n x of n? We will see the proof. Z transform of given signal n equal to minus f to plus infinity a power n x of n given signal z power minus n. So I am going to write this one as a, I am going to rearrange this one as a, because it is a power n, it is a z power minus n. We can make it as a positive n. Summation n equal to minus f to plus infinity x of n a inverse z whole power minus n. Whole power minus n. This is nothing but a capital X of a inverse z. This is a multiplication by an exponential sequence. Next, multiplication by n or the differentiation in z domain. Next property, multiplication by n or the differentiation in z domain. Why I am calling it as a multiplication by n means x of n is multiplied with n. Otherwise, I given other name is differentiation in z domain. That means d by dz of x z. It is a differentiation with respect to z. That is I kept the name as a differentiation in z domain. We will see the proof. We know z trans of any signal is a summation n equal to minus z plus infinity given signal z power minus n. So in this on this proof, I want anyway we got left side x of z, right side this is the equation. I want d by dz x of z means you can take the derivative of x of z one time. Take the x of z with respect, take the first derivative of x of z. We will get a d by dz of x of z. So take the derivative on both sides with respect to z, because it is x of z, here also z is there now. But in the proof I want d by dz. That's why I take the derivative of the above equation with respect to z. Then you will get d by dz x of z. It is a summation, it is not a function of z. So n equal to minus n to plus infinity x of n is not a function of z. Take it as outside. But this one only function of z, d by dz z power minus n. We know d by dz z square means n into z power n minus 1. The same way d by dz z power minus 2 means minus 2 into z power minus 2 minus 1. Same formula can apply. Then take this minus outside. Summation n equal to minus n to plus infinity n into x of n into, I am going to write this one as a z power minus n by z. See, this summation is with respect to n only, not with respect to z. I am going to take this z to the left side and this minus to the left side. Then you will get this is a z power minus n by z. It is a divided by means if you send this one to the left side, you will get a multiplication. Minus z into d by dz x of z is equal to summation n equal to minus n to plus infinity n into x of n z power minus n. This is nothing but a z transform of n into x of n. Next step, this is nothing but, this entire one is nothing but summation n equal to minus n to plus infinity. It is a given signal. If it is a given signal, it is z transform. So z transform of given signal n into x of n is equal to summation n equal to minus n to plus infinity n into x of n z power minus 1. So this entire one is z transform of n into x of n. The left side is proof. Minus z d by dz x. That is the proof. Multiplication by n. Z transform n into x of n is minus z d by dz x of z. Thank you.